Hi, and welcome to this part 3 of our machine shop safety video for novice machinists. And I'd like to start off this video by presenting to you a good friend of mine, Lucky. Lucky the mouse. As you can see, Lucky isn't aware of the danger that he's in. He's not paying attention to his surroundings. And if you do that in a machine shop, well, it's very, very dangerous. Well, old Lucky might be a gambler. Maybe he's aware of what's going on and just takes chances because he's in a rush. Well, we all know that luck is something that runs out. It's inevitable. Now, if you lose at a poker game, well, you lose money, and you can always earn some more. But if you lose in the shop, well, you're going to be losing body parts, and they just don't grow back. Or worse still, your life. You know, you only got one of those. So you have to start right now looking at everything you do from a safety perspective. And that is important in the shop. If you do that, if you look at safety and think of safety before you perform an operation, before you put material in your stores, before you do anything, well, you'll notice that your work environment will get safer and safer. And you may even start to get on people's nerves because you will feel obliged to indicate to other people that this, that, and the other thing are dangerous. You know, some people are oblivious to what's around them, and you have to tell them that highly flammable carpet, well, shouldn't be right in front of the wood stove, or that huge icicle that's hanging from the roof right over the front door, well, should be removed before it kills someone. So, be that pain in the butt. It's important to think about safety all the time. Luck is no way to manage safety, but sometimes it works out. As you can see here, Lucky lucked out this time. But sadly, as I mentioned, luck sometimes doesn't shine our way, and well, eventually Lucky lost. Poor old Lucky, he will be missed. Well, last time we met in the part 2 of this safety video, well, we ended by talking about basic safety for the drill press. And today, well, we're going to start with basic safety for the lathe. The first thing I want to mention, and this applies to all machine tools, is injury by electrocution, and that really isn't a good thing. If you're going to be working on the electricals of your machine, the switch, the motor, the lighting, or whatnot, you have to make sure that there is no power on the machine anywhere. Now, in a small home shop with a bench top style machine like this that runs on 110, well, obviously the best way to do that is to unplug the machine. I mean, there's really no possibility of electrocuting myself once it's unplugged. However, if you have a more industrial type machine that's hardwired into the electrical system, well, you're going to have to make sure or get yourself a kill switch that locks out, so what we call a lockout switch. And that's a switch that you activate or disactivate, and once off you can put a padlock in to lock it in the off position, and that ensures that no one can turn the current on while you're working on your machine. Now, the breakers in an electrical panel can do the trick, but I have problems with that. Oftentimes in the home shop environment, your breaker panel is somewhere in the basement of the house, not necessarily in your shop. And that means that you could get lazy and not run down to the basement to flick the breaker off. And well, obviously that can lead to injury. The second reason is that oftentimes, again, the breakers aren't in the shop area. They're somewhere else. And that means that you could be working on your machine as someone else, elsewhere in the house, flicks the breaker on. And that, again, is a great problem. So make sure the power is off if you're going to work on anything electrical on your machines. Another thing that's worth mentioning here is the guards on the machine. Very important. They aren't just there to be pretty. I mean, they separate us physically from something dangerous. In this side guard, it separates us from the gear train that runs the feeds on this machine from the spindle. Now, gears are terrible things if you pinch a finger in them, because if you do pinch a finger in your gear, you will have your finger run completely through the gear, and what comes out on the other end will not look at all like what went in at the start. So you want to make sure that the power is off when you're working on the gear train as well. But you also want to make sure that the cover is in place. Now, if you don't have guards on your machine, make yourself some. It's very important. Now, this applies as well to pulleys. And remember, when you change speeds on your machine, you want to again make certain that there's no electrical current. And what I've done on my machines is I've set up a small switch on the wall that's clearly visible and that ensures that the power is off when I'm adjusting my belts or changing gears. Now, I don't want to present in great detail the safety for the lathe, the bandsaw, the mill, and the grinders. Well, because we have many videos that cover that already. In all my practical videos, I always talk about safety. But I do want to hit the high spots, the things that people tend to forget or just don't know. And seeing as we're at this end of the machine, the headstock, well, we can start with this hole in the spindle and a major safety problem that is thin, long parts. Now, the hole here is made so that you can insert long parts. It's turned off here, that's why I'm leaning over there, into the spindle and work on them. Even if they're too long, they can stick out. Now, in this case, it's not a big problem because this part is not very long and it doesn't stick out very far. But if it were a very long part, well, that would be very problematic because this piece of stock would, and I don't want to get into harmonics here, but would start to vibrate if it was quite long and was spinning at a high RPM. And for a while it would maintain its shape even if it was wobbly. But sooner or later, wham, centrifugal force would pull that part to a 90-degree angle and would start spinning around like an industrial weed trimmer or grass trimmer. These are powerful machines. This is a very resistant piece of steel. When it starts whipping around, it's going to be tearing stuff off of the walls, off of everything. And if you happen to be in the way, it will be tearing stuff off of you. It could take an arm off, it could take a hand off, it could kill you. So this is very dangerous. But what if we do have a long, delicate piece that we want to let stick out here because I have to, let's say, surface the other end? Well, what do I do? Well, I support it. But I support it in a non-attached way. Now, what does that mean? Get yourself a piece of rigid tubing, and by mounting it on a sawhorse or some kind of base that you can weight down to give it a little oomph, when you come and you bring it close to the end of your spindle, not touching, just close. And that way, your long, delicate piece can rattle around inside there at will. It'll drive everyone crazy in the shop because it makes a lot of noise. But what it won't do is flip out because it can't. It's prisoner inside of this tubing. And that is very important. I remember when I used to teach, the students in first semester were always quite gung-ho to get on the lathes, but they were in much less of a hurry to use the mills. And that is because, well, for a novice machinist, the lathe is a much less scarier tool. And why is that? I always thought that it's because the tool is not in rotation. But less scary does not mean less dangerous. And maybe it's worse that it's not scary because maybe we're not as careful as we should be. Now, cuts on the lathe, two main reasons. And it's not the tool rotation. Cuts usually come from manipulating chips as the machine moves. Avoid pulling on chips. Use a pair of pliers. Very important. And the second is abrupt or rapid movements. When we're moving around, working on the machine, you always have to remember there's a razor sharp cutting tool mounted there. If you have a quick change tool post, and I do not, well, it would be best when you adjust the machine to pull the tool off, do what you have to do and put it back on again. Because when we're moving around, we tend to forget. And I have a few cuts on my arms because that's where you get most of your cuts on the lathe because of those rapid movements. Another problem is this here. Now, the tools on the wall behind the lathe. I'm a big guy, 6'3", and I have ape-like long arms. And I am right-handed. That's important because when I pick up a tool back there, I'm not leaning over the chuck. If I were left-handed and smaller, well, that would be a problem. Why? Well, because other than cutting yourself, because you're moving there, well, there's this chuck that's in rotation. And that's another major safety problem on the lathe, is getting caught in the chuck. Long hair, loose clothes, your hand, chuck key, anything. This is a killer thing. Definitely an arm breaker, but it could be a killer if you get drawn in. And please, no one post in the comments any gory pictures. It really isn't something I need to see. That being said, we avoid leaning over the machine, and as we've said many times before, we avoid long hair, loose clothes, and putting our hands close to what's going on. Very important. Another dangerous situation that most people aren't aware of is injuring yourself while polishing on the lathe using this type of emery strip. And there's no problem with polishing on the lathe, but two things can happen. On an external polishing project, you can easily tear your thumbnail off. That sounds weird, but it does happen quite often. It's never happened to me, but I've seen it happen, and I'll let you know, I don't want it to happen to me. And the other I've never seen, but I've heard of, and that is tearing a whole finger off when internal polishing. So let's take a look at what it's all about. The problem with external polishing is when you apply your emery cloth to the part and you hold it like so, wrapped around the part. When this end here of the strip gets tucked in under the emery cloth, well, this whole thing is going to wrap around it, and it will draw your thumb into it and actually pull the thumbnail right off. The proper way of going about it would be to wrap the part never more than a third of its diameter, holding your cloth well away from the part, and polish this way. The problem with internal polishing is that we tend to, when we're polishing something like this bore, to stick our finger into it with some emery cloth and polish the bore. It's a very bad idea. Should your finger get jammed in there, well, obviously it's going to get twisted because my finger can't stop this lathe. And this is just a little lathe. It's going to twist it and eventually it'll tear it off. And that sounds horrible, up to the point where you realize that as it tears your finger off, it also tears out the tendons at the top of your forearm and at the bottom of your forearm. And that is simply horrifying. So don't polish by sticking your finger into the part. So what are you going to do? You're going to mount your emery cloth on a wooden dowel pin, a dowel pin that's quite smaller than the hole. You don't want something tight at all. And you're going to polish by holding the dowel pin, never putting your fingers close to the part. That's the safe way. It takes more time, but hey, look at me. I still got 10 fingers. Another slightly bizarre accident, bizarre because it's not something we really think about until it happens, and that is being hit on the foot by a falling tailstock. Many machines have stops on them just to stop the tailstock from running right off the end of the ways. But they don't all. This one does not. So go out of your way and make yourself a little stop, as I've done here, to avoid the problem of if you pull strong on the tailstock that it comes right off and falls on your foot. Now the next machine I want to look at is the bandsaw, and it also is quite common in our garages, basements and workshops. So bandsaw, specific safety, and probably the first thing that comes to mind, well, is adjusting the height of the blade guard for each different type of part sawn. Now that means that if I cut a part that's higher or lower than the one that I previously sawed, I should take the few seconds that it takes to readjust the blade guard to its proper height. Now, when I'm cutting, the less the blade is exposed, well, the less chance I have of cutting a finger off. It's just that simple. It only takes a few seconds to adjust. So take that time and adjust it properly. It's a really important safety feature of any bandsaw. Secondly, when you're pushing on a part and you're pushing it through the bandsaw, you want to keep your feet well apart front to back. And that means that the front foot well spaced from the back foot so that you have a stable position. Your front foot should be well leaned up against the machine. And this stable position will help you to avoid hitting your face on the bandsaw if ever the blade breaks. Now I've seen people pushing with both hands on a part because it's a large cut, and that's okay. But if their both feet are behind their center of gravity and the blade breaks, well, they're obviously going forward quite quickly and they actually hit their face up against the side of the machine. If there's a handle or something there, well, we're talking about injuries, broken teeth, and that kind of thing. So really space your feet out so that if something breaks, you're stable and anchored in position. Thirdly, and it's about the same logic, never push a part with your hands in front of the blade. Obviously, if something slides, you don't want to pass your hand through the blade. Keep your hands to each side. Now, that brings up the question that what if I'm working on a small part and I see people holding parts with fingers that are in front of the blade because it's a small part and their fingers are right up close to the blade and it's just terrible. Well, if you're working on a small part and it brings your hands close to the blades, you shouldn't do it. Use a bandsaw vise, use a piece of wood that has been modified to hold your part, use anything that will permit you to keep your hands well away from the blade, even when you're cutting a small part. If you don't get your fingers close to the blade, you can't injure yourself. It's just that simple. Now, another problem is thin section parts, or parts that are difficult to support because they're crinkly. And we're talking here about radiator cores we're talking about heat sinks and this type of material. Now these thin section parts are difficult because they can snag on a bandsaw blade and be drawn in to the guides, and at the same time draw your fingers towards the problem of the blade. So avoid cutting those types of materials on your bandsaw. Those types of materials are probably better cut with water jet cutters or that type of situation. Now, in order to avoid pinching your fingers when cutting cylindrical parts, and I call this the purple fingernail syndrome, and it's excessively painful, well, you should stabilize cylindrical parts using clamps or using indexable drill press vices. And that means that when you're pushing a cylindrical part sideways through a blade, it has a tendency to grab on the blade and start to spin, and obviously pinch your fingers under the part. It's very painful and happens in the blink of an eye. So if you want to avoid that, stabilize it, as you can see in this example. So finally, to avoid cutting your fingers because of a sliding part, we'll notch the surface to be cut before undertaking an angular cut. Now, we want to keep our hands to each side of the blade when we're cutting. But oftentimes when we're cutting a part at an angle and the cut starts to slide on the surface, especially at the start of a cut, well, it can push our fingers towards the blade quite quickly. So in order to avoid that sliding, we should first notch the surface and then introduce the blade at an angle into that notch that we've just produced. It starts the cut in a stable fashion and really helps to avoid the sliding of the part. So we're somewhere around the 22-minute mark, and that's well pretty close to the limit of my attention span. So I think we'll call this one done. Now that means also that we're going to have a part 4 of our lesson 2 safety video, because we haven't touched on milling machine safety, grinder safety, surface cylindrical, and well, we haven't touched on fire safety. But at the end of this video, I think it'd be nice if we had a little thought for old Lucky. Now, Lucky ended his days in the shop, but I disposed of his worldly remains, well, in back of the shop out in the woods, and it's been quite cold since then. So I guess that if a cat or a raccoon has found old Lucky, well, we can say that he finished up as a mouse-sickle. All jokes aside, have fun, be safe, and until we meet in part 4, happy machining.